what is mole. Or in exam, if they ask you to define mole, you are not going to say it is Avogadro's number. Alright. So mole, what is mole? It is a unit for counting particles. Mole is a unit. Remember I said like dozen. Dozen is also a unit. So mole, if they ask you to find mole, the symbol is N, right? And then the unit is, for example, 4.5 mole. So this is the unit. You remember in chapter 1, PV equals nRT. If you are asked to find N, number of moles, the unit should be in moles. So our moles, it is a unit for counting particles. So what are particles in chemistry? Atoms, molecules, ions, even electrons are considered as particles. Okay, so if they say what is mole, please do not directly say it is Avogadro's number. But we know 1 mole, in 1 mole in terms of number, it means 6.023 times 10 to the power 23. Alright, so this is an old definition, how mole used to be defined. Okay, a mole measures the amount of substances that contain the same number of particles as there are atoms in 12 grams of carbon-12 isotope. Now what did you understand by this? A mole measures the amount of substances. You understood that one, right? It is like I said, similar to what we said. It is a unit to measure the amount of substances. Now focus on this. Measures the amount of substance that contain the same number of particles as there are atoms in 12 grams of carbon-12 isotope. Remember, our carbon has 2 isotopes, carbon-12 and carbon-13. Now isotopes, they will have same atomic number but different mass number. So here, like remember the relative atomic mass, how carbon-12 isotope was used as a reference. Yes? So in this case also, carbon-12, meaning what is the mass of this carbon-12? 12 grams, right? So in this 12 grams of carbon is, how much number of carbon atoms will be there in 12 grams of carbon? Is it 1? So imagine here, let's say carbon, okay, carbon, you have 12 grams of carbon, right? So 12 grams is the atomic weight of carbon, right? Yes, here 12. So that is its atomic weight. So in that 12 grams, how many individual carbon atoms are present? Sorry? Avogadro's number, that is what we did earlier, counting by weighing. Remember? You don't have to literally count one by one carbon atom. If you know its atomic weight, 12 grams means in that 12 grams, the number of carbon atoms will be Avogadro's number. So which means in 12 grams of carbon, there is 6.023 times 10 to the power 23 carbon atoms. Meaning 12 grams of carbon is 1 mole of carbon atom. Right? So instead of writing, see, in this definition, instead of saying it is the amount of substance that contains the same number of carbon atom, like instead of using Avogadro's number, they just said particles as their atoms in 12 grams of carbon-12 isotope. Again, here carbon-12 isotope is kept as a reference. Their favorite memo, chemistry, chemistry. Okay, so mole measures the amount of substance that contains the same number of particles as there are atoms in 12 grams of carbon-12 isotope. Now, this is how someone in 10C said, Madam, is there another way instead of writing 12 grams of carbon-12 isotope? Why not we put this number, Avogadro's number, and define them? Yes, there is definition. Okay, so that is how we define in modern days right now. So I wanted to find the definition how mole is defined at present. Okay, this is traditional one, but you should understand this also. Alright, so 1 mole means it's saying like there is Avogadro's number of particles more. So, but what they have written is 12 grams of carbon 12 isotope contains Avogadro's number, like we saw here. Okay. Okay, now example, you just said dozen means 12 number of ways, 1 mole of particle means Avogadro's number of particles. Okay, so this is called 1 mole. Okay. Okay, now we have to see this relationship now between mole, number of particles, atomic mass, and then volume. Now let us start with 1 mole of substance. So 1 mole of substance in terms of particles, number of particles, how much is it? 1 mole of any substance will contain how many particles? Yes, Avogadro's number of particles. Okay, now 1 mole of substance, instead of counting one by one, do you remember in the last class, instead of counting, what did we do to get 1 mole? Weight. So how much do you need to make? 1 mole of substance will be equals to, it should equal to its Avogadro's number is here, it's particle. I'm talking about now the relationship between mole and mass now. Oh, molecular weight, if it is atom, what will you find? Atomic mass or molar mass will be equals to 1 mole of substance. Different substance, remember, will have different atomic weight or molecular weight. And that weight is equals to 1 mole. Okay. Now, if this substance is gas, if you measure this gas at STP, standard temperature and pressure, 1 mole of any gas will occupy 22.4 liters. We call that volume as molar volume. What is it? Molar volume. At STP, it is 22.4 liters. 1 mole of gas means 22.4 liters. Alright? Okay. Then, see. This is the relationship, which means 1 mole means, for example, if it is carbon 12 isotope, that means if I ask you to bring 1 mole of carbon 12, you will give me 12 grams of carbon. Now, in that 12 grams of carbon, how many individual carbon atoms are present? Avogadro's number. So, you see the relationship between mass and Avogadro's number? 12 grams equals Avogadro's number of carbon atoms. And similarly, now, if you have 22.4 liters of gas, you remember 22.4 liter means, I give you an example, if you have 1 liter bottle, you will have 22 bottles, right? Inside that, there will be oxygen molecules, CO2, the gases. Now, if you count this individual CO2 molecules or O2 molecules in that 22.4 liters, they will contain Avogadro's number of particles. Meaning in that 22.4 liters of gas, any gas, if you count this gas molecules, it will be 6.023 times 10 to the power 23. Which means, take any gas. There are so many different gases. If you take exactly 22.4 liters molar volume, you do not have to count. You know there will be exactly how many molecules? Avogadro's number of molecules is fixed. Alright. But, what about this? If you take different gases, if you have equal volume, but will the mass of different gases, will it be same? No, it will depend on its molecular weight now. Gases are always molecules, so it is not atom. So which means 22.4 liters of O2, what is the weight? What will be the weight? O2 molecule. 22.4, you have 22.4 liters of O2 gas, let's say in that. No, I'm talking about in terms of weight. Sorry? O2. So, yes, meaning this, if you have 22.4 liters of O2, the weight will be 32 grams because 32 grams is the molar mass. Now, if you take 22.4 liters of CO2, will it be 32? No, how much will it be? CO2, 44 grams. but both we have taken 22.4 liters. If there is another gas, if you take 22.4 liters, the mass will be different. Are you getting it? Yes? So this one, your calculations will be based on this relationship. Do not forget this diagram, okay? The relationship. Okay, let's try this. We will fill up that diagram, alright? So let's say the particle is now oxygen atom. The particle is atom, right? It's not molecule. So what is the symbol or formula how to write this oxygen atom? Is this atom O2 or is it molecule? Molecule. So atom will be simply O. Yes? Molecule is O2. Oxygen atom, the symbol will be simply O. So if you have 1 mole of oxygen atom, how many individual oxygen atoms will be present in 1 mole? Avogadro's number. So here it should be atoms now. If it is 1 mole of egg, here also it will be Avogadro's number of egg, right? So right now it is atom now. So here also atom, which atom is it? Specifically oxygen atom. So for example, here, this is molecule here, O2. You remember this one? Oxygen has double bond, double covalent bond. This is molecule. Right now it is not talking about molecule, it is talking about you have 1 mole of oxygen atom, individual atom. Right? So 1 mole means we have Avogadro's number, individually you are counting. Now if you count this will be 1. But here, 1. See, this is atom, this is molecule. Molecules, when atoms combine together through this bond, we form molecule. So when I say gases, we are talking about molecule. We are not simply talking about oxygen atom. That is a very misconception we have in chemistry. Okay, especially when you do calculations on this one. Okay, now you cannot count them. So what we can do? Count by weighing. So how much do we need to weigh oxygen atoms to give me 1 mole? 16 or 32? 16 because this is atom, right? Okay, so if it is a gas, it will be 22.4 liters, right? So in terms of mass, 16 grams. Can we say, which means in 16 grams of, if you have 16 grams of oxygen atom, there is Avogadro's number of oxygen atoms. Is that true? Yes. So this is the relationship. Because all this means, in the center, we are talking about they are all 1 mole. 16 grams of oxygen atom is 1 mole. Avogadro's number of oxygen is 1 mole. 22.4 liter of oxygen atoms is 1 mole. Right? So similarly, can we say 16 grams of, if you have 22.4 liters of oxygen atom, the weight will be 16 grams. Can we see that?
Yes.
Yes. So in that 22.4 liter, if you can count this oxygen atom, it will be Avogadro's number. If you understand this table, 90% of your work is done. The calculation will be very easy. You just have to see which relationship the question is asking. We'll practice later on, okay? Okay, now remember different elements, number of atom and volume occupied is same, right? Yes, the only difference is mass. Okay, let's do some examples. Okay, now we are taking CO2 molecule now. So 1 mole of CO2 molecule in terms of number, how much is it? Avogadro's number of CO2 molecules. If you can count that CO2 molecule in 1 mole, they will contain this very big number, right? So in terms of volume, CO2 is a gas. You can also give me in terms of volume, which is 22.4 liters. So what is the mass that we can't count, right? So how much mass are you going to give me if I ask you to bring 1 mole of CO2? 44. Yes, these basic elements you can by heart the molecular mass. It will be easier for you later on. So in that 44 grams of CO2, how many CO2 molecules are present? Avogadro, because 44 grams of CO2 is 1 mole. If you have 34 grams of CO2, is it 1 mole? No, it will be less than a mole. So in that 34 grams, there will be less than this number of CO2 molecules. That calculation we have to do, but you have to know if it is CO2, you have to give me exactly 44 grams to give me 1 mole. So in that 1 mole, Avogadro's number of CO2 molecules. See the relationship there. Okay. Yes. Again. Now let's do some numerical problems. Now you have to understand which relationship. Now can you tell me, after reading this question, the relationship is between mole and atoms, meaning? Okay, so it is 1 mole of hydrogen atom. So you have 1 mole of hydrogen atom. So it is between mole and number of particles. So 1 mole of hydrogen atom in terms of Avogadro's number, the particles is 6.023 times 10 to the power 23. What do we will have here? What do we will have here? Atoms or molecules? Atoms, because they are asking hydrogen atom. So this is atoms of hydrogen. Right? If you have 1 mole, this many hydrogen atoms will be present. Now they are asking what is given? What is given? Moles is given. They are saying calculate the moles. So moles is here. Right? So you have to find this X, and what is given? Number of hydrogen atoms is given. So are you going to start with this value? Or how will you start?
1 mole.
Yes. 1 mole of hydrogen atom. Mole in terms of atoms, it is 6.023 times 10 to the power 23 atoms of hydrogen. So where will you put your X? What is the question asking you to find? Moles or atoms? So moles is on the left hand side here, so your X should be here on the left hand side. This X means you are finding moles of hydrogen atom. So what is given? See, number of hydrogen atoms is given. If you have a big number, 10 to the power 24 and all this, meaning particles is given, which is how much? 1.2046 into 10 to the power 24. So how much moles is it? So you solve for X. X gets multiplied with this, and this 2 gets multiplied. Then X keep it here. The number which is with this one goes in the denominator, right? Yes? So how much moles is it? So this is 10 to the power 24. This is 10 to the power 23. So will it be more moles or will it be less than 1 mole? More, right? So what is your answer?
2.
Is it 2 moles? Okay. So which means 2 into Avogadro's number. Do we get this? Yes? Did you understand how to calculate based on the relationship? I don't know. Ask me then. Okay, now let us move into a little bit challenging question. Set of atoms of helium gas, if the mass was given, is very easy, right? If 10 to the power 24 grams, let's say karma has total this many mass of helium gas, and then he said each balloon takes up 3 grams of helium. So what will you do? You can directly divide this by this. You will get the number of balloons filled.
Yes.
Yes? But the question is not that easy, right? Instead of mass, what is given now? Atoms. So what will you do? How will you solve this? Sorry? So 3 grams of helium, you have this many total number of atoms of helium. So how many balloons will be filled by this many total atoms of helium? How will you solve this? I'm not asking your answer. I'm not worried about answer. I want to see how you get to the answer. Right? Sorry? How will you start or sorry? Instead of 3 grams, easier for you to calculate the number of balloons filled? This is mass, this is atoms. If both were atoms, then what we can do? Divide this by total number of atoms in each balloon. Then you can find the number of balloons, right? Now your task is to convert this 3 grams of helium into atoms of helium first. You have to find out in that 3 grams of helium how many helium atoms are present. That will make your work easy. So 3 grams of helium in terms of atoms, how much is it? Where will you start now? Sorry? 1 mole of helium, meaning in terms of mass, how much is it?
4 grams.
4 grams. The molecular weight of helium is 4 grams. So if you have 4 grams of helium, how many helium atoms is present there? Avogadro's number, because 4 grams is 1 mole. Yes? So you have 6.023 times 10 to the power 23 atoms of helium. Now, in each balloon, it is only 3 grams. So 3 grams helium, which means in that 3 grams of helium, how many total helium atoms are there? Find out. Do not round it off here. Keep it like 4 or 5 decimal places here. So how many atoms is present in that 3 grams? 4 gets multiplied with x, so we have 4x equals Avogadro's number times 3. 3 times 6.023 times 10 to the power 23. This x, so this 4 goes into denominator. Here, please do not round it off. Keep it as many decimal places as possible in this here. 4.5 1 7 2 5, okay, fine, times 10 to the power 23 atoms, meaning in that 3 grams of balloon we have this many atoms of helium, which means you require this many number of helium atoms to fill one balloon. Now what is the total number of helium atoms you have? 3.613 into 10 to the power 24. Meaning how many balloons is it now? How will you find out? So which means 1 balloon here. 1 balloon, this many atoms is required. So how many total atoms do we have? 3.613 times 10 to the power 24 atoms. So how many balloons is it? Keep it x here. Okay, so instead of this, let us write here 1 balloon, this many atoms is required. So this many atoms you have. So how many balloons is it? What will you do? Divide this with this. You will get the number of balloons. So how many balloons is it? Divide this with this. You have to put bracket, my dear. If you don't put bracket, you will not get answer. Open bracket, close bracket, divided by open bracket, close bracket. If you don't put bracket, it will be so many balloons like Kime said. So that's why I asked you to bring calculator in the class. You have to know how to punch the data there. How many balloons is it? 7.9, which is? Can we have 7.5 balloons? 7.9 balloons. So round it off. 7.9 is 7. 8 balloons. Which means in one balloon, if you have this many, okay, so times this with 8, do we get this answer? Check. It should be roughly this number. In one balloon, this many atoms are filled. You have 8 balloons, which means 8 into this should get this number, right? Check whether your answer is correct. 8 into 4.51725 into 10 to the power 23. Do we get this total number of helium atoms?